Hi there. So here I'm going to expand a little bit on the testing that we were talking about last time. So one of the things that you notice, we were looking at this Rcpp interface function that we're using to basically just call this C++ function that implements the nearest neighbors. The C++ function is called predict one to max neighbors matrix. It returns an error status code, and we don't do anything with that error status code right now with code, and that could be problematic. So there are a bunch of different kinds of errors that might be thrown by the underlying subroutine there. They're all defined in this knn.h file. And if we take a look at that file, error too many neighbors, error too few neighbors, error no train data, error no test data. So that could, all of those errors could be happening, and we wouldn't know it. So, to give some example, going back to our command line, we could try to, let's go back to our test file actually. We could think about writing another test here where, test that error for no test data, right? So that's kind of a trivial error, but you could imagine passing in a blank x test x matrix. So x, just a matrix 0, 0. So that's the kind of empty matrix, or x mat 0. That would be maybe a more interesting example. You could think about just a matrix with no observations. What happens to our code in that case? Well, we should get an error, but here what happens is pred prob mat. Well, we get something back, and I guess it's just complete nonsense, right? So what's happening there, right? So what we should do is, so let's go to our, we should write a test that says expect error. Here we don't have to save the result. Let's just call that, and the error should be something like no test data. Okay. So what happens in that case? So in our interface file, what we need to do is we need to look at that status code that's returned there, and so say if status equals error no test data, then stop no test data. So let's see what happens when we recompile after we put that in. So it looks like it compiles fine now, and it looks like it's actually that new test is actually working. So the test didn't stop with any error, so that means that actually there was an error raised in that block, right? So I mean, to clarify, if we run this code interactively, what it means is, here I ran the whole test that block, I didn't get any error, but if I just run that line of code, I do get this error no test data, and so that's because we're intercepting that error status code, and we return an error in that case. So, it would be good if we could write the other ones as well. So let's see if we can go back to that header file and see what those other tests are. No train data, too many neighbors, and too few neighbors, right? So, yeah, I mean, you can imagine writing other tests. Here we have one test for that one error. You would have another test that block for, the no train data error, for the too many neighbors, too few neighbors errors, and hopefully you would be able to catch all of those errors before you return some nonsensical result. So I'm not going to do that all in this screencast, but I just wanted to show some example of how to intercept the error status codes in your interface function to stop with an error in the C++ code, right? So that the key idea is that here you have to return an error status code from your C++ machine learning routine, and then you have to test in your interface function whether or not that status code is equal to some known error value defined in your header file, and if so, you call this stop function. That's defined by Rcpp, and it's going to stop R with this error message. Furthermore, you can test that block for each one of those error messages to make sure that your code really is returning an error when it should. So thanks for listening to this screencast.